This video is about an example that has a very similar design pattern to the coursework, the second coursework, and it's a car tax example. Now the only information we're going to record about cars is their name and the amount of CO2 they emit, and the reason for that is we want to calculate how much tax you have to pay for one, okay? And that depends upon the amount of CO2, the way tax is calculated in the UK, and this is based on a very simplified version of the real UK tax system. So here we've got a main method that does our testing, and it's got basically code that has a scanner, and it reads things in, it checks to see whether you've typed done or not, and if so you've finished. Otherwise it essentially reads in a name, which is a string, and emission, which is an integer. And this doesn't do any actual validation on the input, but we want to keep this simple. Now, having read those two things in, it basically adds a car to a list, and up the top here we've got this car tax list class, and we create an object called list of cars by calling its constructor, and its constructor accepts a string as an argument, and that's going to be the name of the list. And of course I picked something silly, and down here we've got this list of cars.addCar method. So we're going to add in a new car with a name and an emission level. And when we finish this loop, we're going to print out our list of cars. And list of cars is going to have a toString method to make that straightforward. And also we're going to call this print table method to again print out the output, but in a slightly more formatted way. Okay, so let's look at car tax list. Now, car tax list contains the information about our list of cars. At the top here, there's two variables. They're private, of course, because we're not going to allow access outside the class. And we've got the string, which is the name of the list. But for each car, we could store them in here, but it's easier just to create a sub-object called car, which contains all the data about one car. Now, this is a very common design pattern. It applies to the coursework, and it applies to lots of examples. We have one class, which then contains one or more other classes, which contain subsidiary information. So you can see this in, for example, the little example. There's a little object, and within the little object there's a list of stock items. You can see this in the shapes, lists, lines and points example. There's a line sequence which contains a list of lines, and each line in turn contains 2 points. So there's a hierarchy of simpler and simpler objects in each case. In this example there's just a layer of 2. There's the car tax list itself, which contains cars. So we've got a constructor, and all that does is it sets the list name. We've got an addCar method, which is the one we saw being called first in the car tax program here. So this basically accepts a string and an integer, and it adds a new thing to our array list, and what it adds is a new car. So we create a new car object, we set its name, we set its CO2 emission value. We could rewrite this actually. If you find it clearer, we could have written and we could separate these two things out and create a car object, and then just put in there it amounts to the same thing. Here we've got our toString method, which formats the car list as a nice sequence of strings. We've got the first string, which is basically outputs the name of the list, and then rather than directly trying to do each car itself, we are going to loop over our list of cars, and we're going to call the toString method for the car object, which I'll show you in a minute. And that's what gets called here. When we say lm, then that basically says, oh, okay, what we want to do when we refer to a car as a string is call its toString method. So we simplify things. Here we've got our print table method, and again we've got a couple of lines. One is the list name at the top, then there's a header, and notice we're using these \t or tab characters to format the list. And then again we go over the car list using a loop, and for each car we call it getName method, its getEmission level method, and its getTaxRate method to get the name, emission level and tax rate respectively. Okay, now we can look at the car. Now all car does is hold information about one single car, okay, and that is its name, and it's CO2. Now notice we're not actually storing the tax rate here because we're going to calculate that. We've got a few final variables which represent different tax bands. We've got a constructor which calls this set car name and set emission level method, and these will set the name of the car, and they'll set the emission level. This one's a bit more complicated because the emission can't be negative, so if someone tries to set an emission level that's negative, we assume it's very polluting and we set it in the highest band, band D. Otherwise we just set it to whatever value they passed in. And similarly there's a get name which returns the name, and a get emission level which returns the emission level. Now here's our get tax rate method. Now we're not storing the tax rate, we're calculating it every time this method is called. So if the CO2 emission changes, then if we call get tax rate again, then the tax rate will have been updated automatically to the new value. So if someone creates a car with a particular emission level and then changes it, it turns out to be wrong, it should be higher, then they can call set emission level, and they can next time they call get tax rate, it will have updated to the correct tax rate. Okay, so this is a very common thing to do if you've got data that determines other data. In this case the emission level determines the tax rate. You don't have to store that other data, you can calculate it when you need to. And down here we've got our toString method. This is the one that's called in CarTaxList down here in this method to create our formatted output list. Okay, and now there is an alternative way of doing car, and that is to say, well, we could store the tax level. Now this one, you'll see at the top, instead of 2 variables, I've got 3. I've got tax as well. If calculating the tax is an expensive process, you may not want to do it every single time someone asks for the tax rate. You might want to do it when the emission level is set or when the emission level is changed, and then you might want to store it. And that's what this version does. So it's pretty much identical all the way down here until we get to set emission level, and the only change here is at the very end we call this method called set tax rate. Now set tax rate is private, it can't be accessed outside the alt car class, and what it does is it essentially stores the tax rate depending upon the emission value. And now get tax rate simply just returns this variable. It doesn't calculate it here because it's calculated when it's set. This is an alternative way of doing it. Now in the case of the coursework, there's an opportunity to either do it this way or do it the other way, and both is completely reasonable. It doesn't really make any difference which one you pick.